Hi, good morning. This is to introduce the lab, which is Lab 6, Concave and Convex mirrors. I will show you how to do the concave and everything is the same for the convex. We are going to use today, let me go over, this is not your course. Okay, this is the one. Okay, then here week 11 lab is gonna be, this is where you're gonna have the instructions, and this is my basic data. I can also share with you maybe some of these. This is also my data. This is where you're gonna access the simulation. And that one is also like extra, I will say, like my notes here. All right, now the first thing is we're gonna go to physics simulation here. If it did not open, search it, or like I will, let's say, go here. I don't know why, like sometimes it's not gonna work. Then I will, let's say, have it here pasted, and then I am here on the page where it said concave mirror, and this is the simulation. I want to bring to your attention that my numbers are different from yours. Okay, in the handout I'm asking you to use a focal length of 4.2, and I intentionally did that having a fraction so that we will not be very certain about that value, so that we will have difference, a percent difference between the calculated value and the value that we call the theoretical value. In my case, I did choose 3.2. Then this is how you're gonna change the focus. Just you're gonna hit the focus, and here this is 3, and then 3.2, maybe somewhere here. Okay, I'm not certain. And then I will, I need now to move the, the object throughout the whole distance. I intentionally did more points at one side so that to show you how the graph is gonna look like, but I want you to survey with the 9 points all here. Okay, then you're gonna say, maybe I'm gonna have my object here, my object here, my object here, my object here. And every time you're gonna record, can you see? DO means the object's distance, then how far is the object from the mirror, 8.55. The image, DI, is gonna be the image distance, 5.29. This is the height of the object originally, like 0.97, and HI is gonna be the negative 0.6 centimeters. All of these are really units of in centimeters. And my focus today is I want you to use the graphs to calculate what is really the focal length. Okay, and when I did this calculation of data, I will share with you now what, of course, now, okay, this is just for the concave mirror. Now, the second part, I did not actually, I will not include it in the video. Yeah, you want to have, okay, your focus, okay, is you're going to bring it to the other side, and you're going to see here. Now, when I bring my focus here, this is going to be the convex. Okay, then this is the convex, and you need to place the object in front of it. Okay, then here, this is the convex mirror, and again, you need to move your object back and forth, and every time record the values that I'm asking for. All right, then let's go to my other part here where I will show you what I did for this part, this is my Excel sheet. Let me share it with you here. Okay, it is here. Okay, I have, okay, I'm gonna call DO, the object's distance U, and the image's distance, I'm gonna call it V. It's easier. Okay, I want to have all these cells here to be formatted as 2 decimals. Then you're gonna have here format cells, and you're gonna go to number, and you're gonna be sure that it is 2 decimal places all. Okay, for these numbers U, V, and HI and HO. Okay, the object's height and the image's height. I will okay, and then here I did graph. I did graph 1. You will calculate 1 over U and 1 over V, and then I will graph, and from the graph you can see this is what I was talking to you. I intentionally did not record any values here just to show you you know, like wow, you know, like I'm missing points here, but of course, like with Excel is not gonna make a change, but I want to see some of your points, not all of them here. I want to see them here. Now a good strategy here is to start having your Excel sheet and adding the points, and then okay, when I'm gonna come here and see, okay, I'm missing points, then let's try and find some of the points that I might add in this region, so that my points, they're gonna be distributed. I'm asking you to do 9 attempts, and the 9 attempts I want to have them throughout the the whole range. Now also I want you to move your chart to a new sheet. Of course, this lab is going to be a formal lab report. Then you're gonna have the abstract, the procedure, and like all the things that I'm asking for, plus your Excel file. Then you are going to submit 2 files for this lab, the Excel file and also the the formal lab report. And of course here you're gonna have the quick layout. You're gonna label your axes here, and you're gonna have a chart title. Okay, here these are really my numbers. Okay, but of course remember my numbers are based on another F, my F is really different. Also, like I did also this here. Okay, like this is my another, like the other file that I have here. All my things are written, and I will also, in addition, add more things to here. I will calculate M from distances measurement, then is gonna be the image distance divided by the object's distance, and I will measure also the magnification. M, it is the magnification from the image's height divided by the image's height divided by the object's height. Okay, and here is part 1. This is a better graph that I did. Okay, this is part 2 for the convex. I did the same thing, and this is the graph, and here is my results. Okay, for my concave mirror and for my convex mirror. Then this is how it is. It should be looking like. Okay, you will not be able to access this graph, and I will say this is what I did to complete my all data. Remember, these here they are going to be your data. Okay, this table here is going to represent your data. This one is going to represent your calculations. Okay, then this one is going to be under data section. This one is going to be under calculation center section, and of course these are under results section. Okay, what else? Okay, I want to also share with you another file just to show you. Okay, then I will remove this. Now I will leave that and I will go to this one here. This is where I have that. Okay, this is the instructions. Of course, task 1, it is to the our objective is going to be to determine the focal length, and your value is 4.2 for both. For my video F, it was 3.20 centimeter, the first set of data. The second one, it was, I think, 3.69. Okay, and here DO is the object's distance. I will call it U, the image's distance. I will call it V. HI is the image's height, and HO the object's height. And here where I have collected my data. Now this is the equation that we are going to discuss in the lecture. 1 over U plus 1 over V equals 1 over F. Now I can rearrange my terms so that they will be 1 over U equals minus 1 over V plus 1 over F. And this is the equation in the form of Y. My 1 over U is going to be my Y. My M is going to be -1. And this is the intercept. Then my intercept is going to be 1 over F. And in order to calculate my F, I should take 1 over C. And then my focal length here was the one that I calculated from the graph was 3.37. Remember I told you I intentionally did use like having a fraction that you will not be certain about, so that we will have our values, because this is like almost a simulation. It's not actually an actual experiment, so that our values will deviate from the true value. Okay, of course, this lab is going to be due by this coming Sunday, and I hope you will not find any difficulties. In case you will find any issues, please, contact me. Of course, you need to calculate the % difference between the theoretical value and the experimental value in both cases. And again, a reminder, it's going to be a formal lab report, which means you have to submit 2 files, the Excel file and also the file that is the Word document, which is the formal lab report, and the Excel sheet. Thank you.